Hello everyone, welcome back. In a previous session we were discussing about the module 4 of Unix system programming, that is signals. Okay, so we have discussed the concept of signals, signal API, signal mask. Okay, in today's session also we will continue with the discussion of some more concepts of signals. We know that there may be some of the signals that are pending for a process. Okay, so we can get a process can get the information of the pending signals by using this sig pending API. The prototype is like this. The header file, it includes signal.h and the name of the API is sig pending. Okay, and it has got one argument and the return type is integer. Okay, so this API returns 0 if this is executed successfully and -1 if there is any error. Okay, so here we have the argument sig mask, okay, which is of type SIGCHLD_T. So here what happens, whenever the process is invoking this API, so the signals that are pending for that process will be set into this signal mask, set into this sig mask argument. Okay, so now we shall discuss this with a program. So this program illustrates the usage of sig pending API. Okay, so this program will check whether the signal SIG term, okay, sig term is pending for the invoking process or not. Okay, so this is the include statements, and next we have a variable, we have an sig mask which is of type SIGCHLD_T, and we are calling the function sig empty set and we are passing this sig mask. So we have discussed in the previous session itself. So this API will clear all the bit flags of this particular signal mask. Okay, and next I am checking sig pending for this sig mask. If it is equal to -1, okay, in that case I am checking, that means if this is called, what will happen? So sig pending will check for the pending signals for the calling process. Okay, and it will set those signals to the sig mask variable. So now the pending signals for the calling process will be set in the sig mask variable. So if this returns -1, in that case error, so I am printing the error message by using this p error. Okay, otherwise that means if it is executed successfully, so what will happen? The pending signals for the calling process will be set to the variable sig mask, right? So I am just trying to print it. Okay, so in the else part, see out sig term signal is, I am just checking the condition here. If you remember, in the previous session we have discussed about this API. So this API will return 0 if the particular signal is present in the, if the particular signal is not present in the signal mask, it returns 0. Okay, suppose this particular signal is present in the signal mask, in that case it returns 1. Okay, so we have already discussed about this in the previous session. So here we are checking that by using this sig isMember API, we are passing this sig mask variable, and next I am checking the sig term signal. If this is present inside this sig mask, then I am making use of this conditional operator. So complete this will become 1, that means it returns true. So suppose if this is present, it returns true, right? In that case I am just printing set here, sig term signal is set. Let us assume that this sig term is not present in this sig mask variable. In that case unset will be printed. So finally, by making use of this sig pending, we are getting the pending signals for the calling process. Okay, and then we are just checking whether in the list of pending signals, whether this sig term signal is present or not by using the sig isMember API. Okay, so this is all about the program. So the Unix system version 3 and version 4 supports some more APIs, okay, and I have listed those APIs here. So first API SIGCHLD, okay. So this API will set the signal named by signal num to the signal mask, okay. So this API, what it will do, it will set the particular signal that is identified by the signal underscore num to the signal mask. So what is the signal num? We have already discussed this in the previous session. Signal num is nothing but an integer flag representing the signals, right? So here, so this particular signal with the signal number will be set to the signal mask of the calling process, okay. And next we have SIGRELSE. So this removes the named signal that is identified by the signal num from the calling process, okay. And next one more, SIGIGNORE. So this signal, so what it will do, so this API, so it will remove the, it will change the named signal that is identified by the signal num to the default action by using SIG underscore DFL. So in the previous session I have told you that SIG underscore DFL is nothing but the manifested constant that corresponds to the default action of the signal, okay. So in the SIGIGNORE API, what is happening? So if this API is invoked, in that case the signal that is identified by the signal underscore num will be converted with the manifested constant signal SIG underscore DFL, okay. So last one, SIGPAUSE. So here the particular signal that is identified by the signal num will be invoking, will be executing a user defined signal handler function, okay. So this will execute the user defined signal handler function, and what will happen, the current execution of the process will be suspended. So the execution of the process will be suspended until it gets an interruption from the signal, okay. So that is about the SIGPAUSE API. So these APIs are supported by Unix system version 3 and then version 4, okay. So now let's move on to the next concept. The next concept is SIGAction. So that is nothing but the signal action. So that is represented by SIGAction API, okay. So this SIGAction API is replacement of the signal API in the Unix and POSIX systems, okay. So it works similar to signal API. So and also this SIGAction API is called by a process in order to set up a signal handler or a signal handling function for all the signals which for all the signals that the process deals with, okay. So it is called by the process to set up signal handling functions. And this SIGAction API, it also used to block the signals. Suppose if the process is executing an API, if the process wants some of the signals to be blocked, in that case also this SIGAction API can be used by that process. So basically this SIGAction, it can be called by the process either to set up the signal handling function for all the signals, or it can also be used to block the signals whenever the process is executing some other APIs, okay. The prototype is like this. It includes signal.h and then the name of the API is SIGAction. It has got 3 arguments and the return type is integer. So if this is executed successfully, it returns 0, otherwise -1, okay. So out of these arguments, the first one is signal underscore num. So we already know that signal underscore num is an integer flag representing the signals, okay. And the second argument and the third argument, so action and old action, okay, both of these arguments are of type struct SIGAction. So this structure is defined under signal.h and this is the structure, Okay. So struct sig action, it has got 3 members or 3 variables. So first one SA handler, and then SA mask, and then SA flag. Okay. So first one, this first argument is similar to the second argument of signal API. If you remember, signal API has 2 arguments. The first one is signal number, and the second argument is nothing but a function pointer to the user defined signal handler function, right? So same way here, this is similar to the second argument of that signal API. So nothing but it's a function pointer to the signal handling function. So it can set the values such as SIG underscore IGN, SIG underscore DFL, or any other user defined signal handling function. Okay. So we got to know that what is this SIG underscore IGN and SIG underscore DFL. These two are manifested constants, okay, representing the default action and the ignore action with the signal. So the first argument can be set with either of these 3. So it can have the ignore option, or it can have the DFL option, or it can have the any other, it can act as a pointer to the user defined signal handling function. Okay. And the second argument is SA underscore mask. So this variable or this member contains the additional signals that has to be masked. Okay. So that has to be blocked by the process. So it contains the additional signals that has to be blocked by the process. And the third argument is, the third variable is SA underscore flag. So I will explain about the SA underscore flag later. Okay. So this is about the Sig Action API. So now let's discuss this API with a program. This program illustrates the usage of this Sig Action API. Okay. So the header statements include statements. Okay. And next we have a user defined function. Actually this is nothing but the signal handling function. Okay. So call me function, it is nothing but the signal handling function. So call me function has got one argument, that means a particular signal number, and what we are doing here, we are just printing that catch signal, that particular signal. Okay. Sig underscore num. Since it is not returning anything, the return type is void here. And next main function. So main along with the command line arguments. Okay. So we have the variables, we have declared variables sig mask and then action and then old action, which is of type struct sig action. Okay. So first what we are doing here, sig empty set sig mask. So we are calling the API sig empty set. So sig empty set, what it will do, it will clear all the bit flags or all the signal flags of this particular signal mask. Okay, it clears everything. So in next we are calling another function, that is sig add set. Okay. So what we are adding? We are adding this particular signal, that is sig term signal. So we have already discussed that sig term signal is for process termination. Okay. So this sig term is getting added to this signal mask. Okay. So if this is executed successfully, in that case what will happen? The sig term will be added to sig mask. Otherwise there might be some error. So error means it returns -1. So I am just checking the condition here, whether the return type of the sig add set is equal to -1. So this is with the one condition. Okay. Or I have or here, or I am calling one more API, that is sig process mask. Okay. So what I am doing, I am just adding this sig set mask followed by the signal mask and then 0. So if you remember what is the importance of this sig pros mask, so it will block the list of signals that is mentioned here. Okay. So what we are blocking here, the sig term, if I am making use of this as the command value. So if you remember, sig pros mask has the 3 arguments. The first one is the command, and second one is the new mask, and the third one is the old mask. Okay. So new mask means this one, the updated new mask which contains sig term. Okay. So for that, so sig set mask means for the current signals, along with the current signals, again the sig term, sig mask will also be added for this particular process. So that is implemented by sig pros mask API. And again, if this is executed successfully and this will be added, if there is any error, it returns -1. So here with this if condition, we are checking, we are invoking 2 APIs. One is sig add set and another one is sig process mask. Okay. If either of these returns -1, we are printing the error message saying that set signal mask error. Okay. So let us assume that it is executed successfully. So what will happen further? So here, so we have sig empty set. Okay. So sig empty set means, so it clears everything that is present in this SA mask. Okay. So here we are making use of 2 signal mask here. One signal mask is this one, which is of type sigset underscore t, and another one is with the structure variable action. Okay. So action dot SA underscore mask. Okay. Since it is a structure variable, we are making use of dot here. So we are clearing the structure variable mask of this particular action by using this sig empty set API. So next, sig add set. So action dot SA mask comma sig SEGV. So this is segmentation fault signal. So we have discussed in the previous session. Okay. So what is happening? We are trying to add this signal to this particular action. Okay. So since we are adding this particular signal to this action mask means, again this signal will be blocked. Okay. So that is the concept of signal mask, right? Signal mask means it contains the list of signals or set of signals that are blocked for the calling process. So what I am doing here, I am making use of this, I am using this particular sig SEGV signal. Okay. So that will be blocked for this particular signal or for this particular process. Okay. So next, what is happening? So SA handler, we are assigning the SA handler for this action variable with the function call me. So call me function means this one. As I already told you, it's a signal handling function. Okay. So it's a signal handler. I am assigning that particular call me function to this SA handler. Okay. Later SA flag is initialized to 0. So as I already told you, I will explain about the SA flag later. So as of now, don't worry of this SA flag. Okay. So action is of type struct sig action. It has got 3 members. One is SA handler and another one is SA underscore mask and third one is SA flag. So what I am doing here, I am setting the values of these members of this particular struct variable. Okay, clear? So next, what I am doing here, so here we are calling the API sig action. So sig action API is called. So what we are passing, the first argument of sig action is signal number. So that is nothing but the sig int comma action and then old action. So old action will be retaining the previous signal action for the calling process. Okay. So I am just invoking this API with these arguments. If it is executed successfully, no problem. If there is any error, it returns -1, and through the program we are trying to print the error message. Okay. So after this, pause API. So here this pause function, so it will currently suspend the execution of the process until it gets an interruption from the signal. Okay. And at last we are printing argv of 0 exists. That means particular signal action exists or not. Okay. So this is about the signal action. So what we are doing here in this program, through this program we are actually setting the process signal mask with the sig term signal. Okay. So process signal mask will be having the sig term. So through this program we are performing 3 actions, so or 3 events. First one is we are setting the signal mask with the sig term signal. Okay, that is first one. And second one, we are blocking the signal SIG, SEGV. Okay, so we are blocking that segmentation fault signal for the process. And the third one, for this signal SIG INT, we have, what we have done, we have created the user defined signal handling function for this SIG INT, because I am passing this action variable, right. So this action variable has got the handler call me. So that is assigned for sig int. So in other words, for this signal handling function is assigned. So that is nothing but that call me signal handling function. Okay. So this is about the sig action API. Okay. Okay. So just now we were discussing about the sig action API, right. So in that the second argument is of type struct sig action. As I told you, it has got 3 variables or 3 members. One is SA handler, SA mask and SA flag. I told you that I will explain about the SA flag later. So now I am explaining about the SA flag. So SA flag is a special flag that is mainly used for some special handling functions for the signal. Okay, it's a flag that is used for special handling of the signals. So in POSIX systems, the values for SA flag is 0 or SA underscore no CLD stop. Okay, SA underscore no CLD stop. Suppose this SA underscore no CLD stop is assigned for this flag. That means if the flag is set with this value, in that case the parent process will get the message or it will get the notification if the child process has been terminated. Okay. So if the child process has got terminated, in that case, so the parent process will be notified with the signal SIGCHLD signal. Okay. So this is whenever the child process is terminated. Okay. Suppose if SA flag has got the value 0, in that case the parent process will get the notification from the kernel with the SIGCHLD signal even if the child process is terminated or stopped. Okay. In the second case, only if the child process is terminated, this signal will be generated from the kernel to the parent process. Okay. But not with the stopping action of the child process. But here if the value is 0, in that case the parent process will get this signal even if the child process is stopped or terminated. Okay. So similarly, the Unix system version 3 supports 3 flag values for this SA flag. One is SA underscore reset hand and another one is SA underscore restart. Okay. So if the first one is set, in that case what will happen? So the signal number will be start execution with the default action of the signal instead of the user defined signal handling action or user defined signal handling function. Okay. So reset hand, here if this is set for this SA flag, in that case the signal num will be started with the execution with the default action of the signal instead of the user defined signal handling. Okay. In the second case, if this is set, in that case if a process is performing the execution of a particular system call, let us assume that a process will be executing a system call, and if this option is set, that is restart option. So in that case, if the process has got some signal notification, in that case the control will be returned to that particular signal handling function, the execution continues there, and the control will be returned here, and the system call, the execution of the system call will be restarted. Okay. Suppose if this option is not set, in that case what will happen, that particular system call execution will be aborted. So the kernel returns -1 with the function, and it will set the error no, that is error flag. Okay. So the kernel will set the error no to EINTR, error status flag. So this is about the SA flag. So now let's move on to the next concept. The next concept is the SIGCHLD signal and the Weight PID API. Okay. So we already got to know that this signal will be generated to notify the parent process if the child process has stopped or terminated the execution. Okay. If the child process is terminated or stopped, in that case parent process will be notified by this signal. And what about this Weight PID? We have already discussed about Weight PID in the previous module. Okay. So this will suspend the execution of the process or the parent process until the child process that is specified by the particular PID will change its state. Okay. Until the child process change its state, the execution of the parent process will be suspended. So that is Weight PID. Okay. So whenever this SIGCHLD signal is generated, so the different events may occur. So first one, so what will happen? So this, the parent process might accept the SIGCHLD signal with the default action. So with the default action it might accept. So what might be the default action? So this, unlike other signals, so it performs similarly like how everything works fine. Okay. But the difference here is whenever the parent process is invoking Weight PID, in that case the execution or the suspension of that particular process will be if the parent accepts the default action of the SIGCHLD. So unlike other signals, it does not terminate the parent process, but here whenever the parent process is waiting for the child process, in that case what will happen, the child will be entered into the, the parent will be entered into the sleeping mode. So first the kernel will awake the parent process, that means the parent process will be awakened. Okay. And then kernel will clear the process table. Okay. The kernel will clear the process table of the parent process. So that is with the default action. And in the second case, so the parent process might ignore that SIGCHLD signal. In that case nothing will happen, so the signal will be discarded. So the parent process will not be disturbed even if it is executing the Weight PID API. Okay. Even if it is waiting for the child process, the execution, so that will not affect in this case because this signal will be discarded. Okay. And what about the third one? Here a particular user defined signal handler will be executed for this SIGCHLD. Okay. So in that case the parent process will be executing the, or it will be waiting for the child process. So what will happen? So the control will be transferred to that particular user defined signal handling function. The execution continues, and then again this Weight PID function or Weight PID API will be executed, and then the process continues. Okay. So this is about the SIGCHLD signal and then the Weight PID API. So in today's class we have discussed about the pending signals for the signal and then Sig Action API. So under that Sig Action API we have already discussed a program, and then we have discussed about SA flags. So the next concept was the SIGCHLD signal and the Weight PID API. So let's continue in the next session. Thank you.